Hello everyone and welcome to Decito MCBM. Today we are starting the GCSE Chemistry course following the national curriculum of the United Kingdom as set by Edexcel. This video is the first of a series on key concepts in chemistry that are needed for almost all other aspects. Today's episode is on states of matter. So, what is a particle? Well, a particle is a single unit of an element or compound. This can be as a single atom, as in mercury, or a molecule consisting of more than one atom, as in water. As shown, there are three main states of matter needed for GCSE. One is a solid, one is a liquid, and then finally gas. A common question in chemistry is to describe the arrangement of particles in a solid, liquid, or gas. Let's now move on to how to answer. When describing a solid, there are 3 points you must always include. These are 1. That they are closely packed and all touching. 2. That they are arranged in a crisscross pattern known as a lattice. And 3. That they vibrate around a fixed point. If you include all three of these points on density, arrangement and movement, you will likely get 3 marks out of 3. Similarly, in a liquid, there are 3 points you must include. 1. That the particles are closely packed and all touching. 2. That they're arranged randomly, and you must say randomly. And 3. That they move over each other, also randomly. Finally, when describing a gas, the 3 points are as shown. That they are randomly dispersed, they move fast in all directions, and the particles occasionally collide with each other and the container walls. You may also be asked to compare the physical properties of each state of matter. Solids maintain their shape, volume and density as a result of their closely packed particles. They also cannot be compressed for the same reason, and a solid is likely to diffuse very slowly, if at all. A liquid maintains their volume and density for the same reason as in solids. However, they do not maintain their shape, but fill up and take the exact shape of the container they are in. A liquid is also a fluid, therefore flows from an area of high altitude to low altitude, much like in a waterfall. A gas, however, is very flexible, as despite it being a fluid and being able to flow, it does not maintain its shape, volume and therefore density, depending on the shape and size of the container it fills. Unlike solids and liquids, gases can be compressed because the particles are not touching, therefore can be pressed closer together. In order for a substance to change state, it must have energy to overcome forces of attraction between particles. As we put thermal energy in, the particles will vibrate more, and once it gets past a certain point, these forces are overcome, and the next state is accomplished. These special points are what we call the melting and boiling points. As shown in the diagram, if the reverse happens, i.e. a substance is losing thermal energy, the particles slow down enough for these forces of attraction to have an effect, so the previous state is achieved. This is known as a physical reaction, meaning the reaction is reversible and creates no new products. Here we have an example of a state change graph. As you can see, for the most part, as the thermal energy increases, so does the temperature. However, the 2 points represented as a straight, flat line are where state changes happen. It is shaped as such because, once past the melting or boiling point, any extra energy put into this substance is used as kinetic energy by the particles to overcome the forces of attraction between them, and vice versa. Thank you for watching, and I hope this has contributed to your knowledge of the key concepts in chemistry.